let's write the merge routine. So we're going to have three indices. We're going to have I, that's an index into 1. We'll have j, that's an index into array 2, and k, that's an index into the output array. We'll set all those starting out at 0. So we're going to look at the first element in 1, we're going to look at the first element in 2, and we're going to add one of those to the first spot in the output array. And we will keep looping until we've looked at, we filled up the output array with all the elements that it should have in it. So our merge you can kind of think of as a zipper. Well, maybe not a perfect zipper, because we're not always going to alternate between the two sides. But we're going to say, well, if the first element in the left side is less than the first element in the right side, then that's the one that should go into the current output slot. And how do I know that this first element in the left side, so the first element in 1, is the smallest element in that side? Well, that's going to be our assumption when we're calling merge. So let me jump back to here. And when we call merge, we're passing in two sorted arrays. That's the important part, is we can make that assumption that merge is always operating on sorted arrays, which means that 1 is in sorted order and 2 is in sorted order. Okay, so with that said, now we've got the smallest element inside the output array. We've got an increment where we took that item for. So like I said, I is going to be our index into the first array, 1, and j will be our index into the second array. So whenever we pull an item from one of the arrays, whether that's 1, we've got to increment I, or if it's 2, we've got to increment j. Don't forget we've got to increment k every single time. So that doesn't belong in the if or the else. We always increment k because we're always adding at least one element into the output array. And this pseudocode here is not necessarily perfect because it assumes that nothing goes wrong if you have a bad index. So just for example, let's say that here's our 1 array and here's our 2 array, and let's just say it so happens that all of the elements inside 1 are less than all of the elements inside 2. What we'd end up with is we'd say, okay, well, I starts here at the first element and j starts here in the second array. I starts at the first element in 1, and maybe I should label that 1, and this is 2, and j starts at the first element in 2. Well, what happens when we continually add things from that side? Well, I will go past the end of the array, so all I'm saying here is that we don't have any special handling for what happens if you've looked at all elements in one array and then started adding from the second array. Alright, well, what's the total running time? So the total running time, since this is a non-recursive function, it's pretty easy to just go line by line and calculate them all up. So I'll pause here and let you compute the total running time, so line by line for this function.